So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see how to find a single element where each elements are appearing thrice. Okay. So let's take one example. Okay. So here we have an array in which we can see that element 2, 4, 8 are appearing thrice, but 7 is appearing only once, right? So we have to return 7 as an answer. Okay, so it is guaranteed that one element will be appearing only once, other all elements will be appearing thrice. Okay, now let's see that how we can solve this problem. But before that, let me tell you that we have started a series on DSA. If you know the fundamentals of DSA but getting stuck while solving the problem, this series will be helpful for you. If you are preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Thank you. Now, let's see that how we can solve this problem. So, the first approach will be always a brute force approach. So, approach 1, let's say brute force. Okay, now here what we can do, we can start from first element. Okay, and then we will check how many times it is appearing. Okay, so for 4 it is appearing 1, then 2, then 3. Okay, see if the count is 3, then we will move forward. Then after that we will have the count of 2. So here we can say that the count is 1, then 2, then 3. Here also the count is 3, move forward. Go for 8, 1, 2, and 3. Again count is 3. Go further. So if you are searching for this element, start with index 0. It is 1, 2, and 3, right? The count is 3. Go further. Search the frequency of 7. So here we can see that starting from index 0, the only occurrence is 1, right? So since the frequency is 1, then we have to return 7 as an answer. Okay, so this is the first approach. Now if you talk about the time complexity, since we are searching for each and every element, okay, so it will be order of n square, and the space complexity will be order of 1 because we didn't take any extra space. Here this is a very simple approach, that's why I'm not going in deep. But if you want to know what will be the code, you can see the description box. In that I have given the link of the Medium page where I have shown each and every code of every approaches. Okay, now so interviewer will not be happy with order of n square, right? So we have to optimize it. So approach 2. Okay, here what we can do, we can take the help of hash map, or let's say we have to find out, we can store the frequency of each and every element. Okay, so either you can use frequency array or hash map. Here we will be counting the frequency of each and every element, and we will be storing in the hash map. So for 4, the frequency is 3. For 2, the frequency is 3. For 8, the frequency is 3. For 7, the frequency is 1. Right? Only these elements are present: 4, 2, 8, and 7. Now, what you can do, either you traverse in this array or in this hash map. Okay? So in both of them, you will get to know 7 is having the frequency of 1, so you have to return 7. Okay, so I'll give you the basic pseudocode for this approach. So first of all, you have to create the hash map. So I will be writing in a comment create hash map because you know how to create the hash map. After that, run one for loop in which I will be running from 0 to n. and we have to store the frequency of each and every element. So the name of the hash map is hmap dot put. Here I'm going to use the get or default method. So a of I comma hmap dot get or default. If you don't know what is get or default, you can Google it. A of I comma 0 plus 1. Okay. With this, the frequency of each and every element will be stored inside the hash map. Now what you can do, you can traverse this array. Okay, what you can do here, go each and every element and try to find what is the frequency stored in this hash map. So for 4 the frequency is 3, for 2 the frequency is 3, for 8 the frequency is 3. If the frequency is 3, you have to move forward. For here also 2 also the frequency is 3, but while coming on this 7, we know that the frequency is 1, so just return 1. So for I will be running from 0 to n. What you can do, hmap dot get a of I. Okay, if it is returning 1 at that time, we have to return the element. So return a of I. That's it. If it is not return, if it is not equals to 1, then you have to simply move forward. Okay, now so that's it. This is the code, or let's say pseudo code. Now if we talk about the space complexity first, here we have taken the help of the hash map. Okay, so the space complexity will be order of n. Okay, and if we talk about the time complexity, this for loop is running for n time, and also this for loop is running for n time. Okay, so n plus n, which will be 2n, now that will be boils down to order of n. Okay, now we have optimized the time complexity from order of n square to order of n. Okay, but the overhead is now space complexity, which is order of n. Okay, we have to optimize this as well. Now what you can do, the third approach is a little bit trickier. Okay, but don't worry, I'll try my best to help to simplify this. Okay, now let's take one example in which each and every elements are appearing thrice. Okay, so 2 2 2 4 4 4 8 8 8. Okay, now this is an array. Okay, and each and every element I am actually representing in the binary format. Okay, so for 2, the binary format will be 0 1 0. Okay, for the second 2, it will be same. For the third 2, again same. I will be writing the binary representation of each and every element. Okay, now here is the binary representation of each and every element. Okay, now let's say I want to count this set bits. Okay, that in place 0, in place 1, in place 2, and in place 3. Okay, in every place I want to count this set bits. Okay, so in this place the number of set bits are 0. Okay, so the answer will be 0 because none of the bits are set. Now if you go forward, in this place the number of set bits are 3, right? So I'll write 3 here. Now if I go forward, in this place the number of set bits are again 3, right? So 3, and here also the number of set bits are 3, right? Now we can see that due to each elements are appearing thrice, okay, we are getting the answer with respect to divisible by 3, right? But let's say if I add 7 to it. So 7, the binary representation of 7 is 0, 1, 1, 1, right? Now due to that, 7 here is a conflict. Why? Because each and every elements are appearing thrice. Due to that, the sum of each set bits are in the divisibility of 3, but due to 7, now my sum will be get affected. That means here it will be 1, this will be 4, this will be 4, and this will be 4. All right, now what can I do? I'll simply do divisible by 3. So 1 modulus 3, I'll get my answer as 1. For this 4 modulus 3, I'll get my answer as 1. For this 4 modulus 3, I'll get my answer as 1. Sorry, this is actually 3, not 4. And for this 3 modulus 3, I'll get my answer as 0. Okay. From here, we got to know that 0, 1, 1, 1. This number has been added recently. Okay. And due to that, I'm not getting the sum, the count of said bit, okay, not divisible by 3. Okay, so we can simply return 0, 1, 1, 1, that is 7, which has the frequency of 1. I hope you got this. Okay, using this approach, we are going to solve this problem. Okay, so from here we should know two things. First, how to check whether on X position whether the bit is set. Second will be C. From here we got to know that the remainder is 0, 1, 1, 1, and simply that is our answer. Okay, so in our answer we have to set this value. Okay, so if I make if I take answer which I have to return at the last, initially the value of this answer is 0. Okay, now in place 0, in place 1, and in place 2, I have to set 1 bit, right? So if I convert this 0 in binary, it will look like this: 0, 0, 0, 0. Now in place of 0, I have to set 1. In place of 1, I have to set 1. In place of 2, I have to set 1. And this will be our answer. So the second part will be how to set in ith position 1. Okay, now let's see one by one how to check whether in ith position bit is set or not. Okay, so here I will be using a function which is count set bit. Okay, now I will be having the value x, and in which position I have to check whether the bit is set or not. So this will be I. Now let's take one example. 1, 0, 0, 0. The decimal representation of this is 8. Okay, and I want to check for this position it is 1 or not, which we can see that it is 1. So position for this is 0, this is 1, this is 2, and this is 3. So the value of I is 3 and the value of x is 8. Okay, now what I'll do, I'll simply do the right shift by 3. Okay, by 3 because of I. So if I do right shift by 3, So this bit will be here. I hope you know that how to do the right shift. If you don't know, I'll suggest you to please watch my previous video, and other all will be 0 as it is. Okay, we are actually putting by ourselves. And what about this bits? It will simply drop it off. Okay, now I'll simply do and with 1. Okay, now if I do and with 1, my answer will be 1, right? So if my answer is 1, that means the bit is set. Okay, and let's see if the bit was not set here. In if it is 0, then if I do and with 1, I'll get the answer as 0. Okay, so due to that, I can see that at that position the bit is not set. Okay, so it will look like this: if x right shift I ANDed with 1. Okay, if it is giving me 1, simply return 1, otherwise return 0. That's it. So this is the pseudocode for this. Okay, now let's check that how to set 1 in ith position. Okay, now I'll have x initially as 0. Okay, now I want to set 1 in third position. Okay, so initially the value of x is 0 and the positions are 0, 1, 2, 3. So in this place I want to set to 1. Okay, now let's see how we can do that. See, what if I take the number as 1? Okay, this is the 1. The binary representation of this is 0, 0, 0, 1. Okay, and if I left shift this number by 3. Okay, so if I do that, the answer we will be getting is 1, 0, 0, 0, because I have done 1 left shift by 3, right? So this will be the answer. Okay, and what we have to do, we have to simply OR with the x. Okay, so initially the value of x is 0 and I am doing OR with this value. Okay, 1, 0, 0, 0. Okay, so if I do OR, I'll get my answer as 1, 0, 0, 0, and that's it. In this way we can set the bit at a particular position. Okay, now let's say in this only I want to set 1 in position, let's say 1, so I will be 1. Okay, similarly what you have to do, you have to do this: take the number 1. Okay, and left shift it with 1. So due to that, initially the value of 1 is, so binary representation of 1 is 0, 0, 0, 1, and if I do a left shift with 1, I'll get the answer as 0, 0, 1, 0. Right, now I have to do OR with of these two. Okay, so 1, 0, 0, 0 or 0, 0, 1, 0. If I do OR, I'll get the answer as 1, 0, 1, 0. Right, okay, using these two methods we are going to solve this problem. Now the thing is that since we are dealing with the integer value, okay, now the number of bits in the integer data format is 32. Okay, now the thing is that here, because of the simplicity, I have taken 4 bits all the time, but actually in the computer there will be of 32 bits in total, so if I talk about the value 4, okay, so here I have taken 0, 1, 0, 0. Okay, but now this we can see that it is simply a 4 bit. Okay, but in computer there will be 32 bits, so here there will be zeros, there will be total of 28 zeros. Okay, and so on. While writing the code, what we have to check each and every bit. Okay, so due to that we have to run the for loop for 0 to 31. Okay, so here is the pseudocode int find single. So we are passing the integer array, okay, and the size, which is n. Okay, initially the value of answer will be 0, and after that, using the for loop in which I will be running from 0 to 31, right? I hope you know this. Now initially the count bit will be 0, because in every position we have to keep the track of the set bits. Okay, here in this place the set bit is 1, the count of the set bit is 1. Okay, so count bit will be 0 initially. Now using the second for loop in which j will be running from 0 and it will be gone till n. Okay, now we are counting in the ith position whether the bits are set or not. Okay, so if count set bit while passing a of j and I. Okay, if we are getting the answer as 1, okay, then we are counting the bit in the ith position, so count bit plus plus. Okay, after running the inner for loop we are going to check if the count bit modulus 3 is giving us 1, right? If it is giving us 1, then we have to set the 1 in answer, and that too in ith position. So answer is equals to answer or 1 right shift I. That's it, and we are done. At last we have to return answer. I hope, I know that this is little trickier, but what you can do, you can rewatch this video second time, and please try to dry run it by yourself, then you will get to know that what is happening. Okay, and I hope you know that what is this. This is simply a function which I have written it here. Okay, you can copy it from here. Now if you talk about the time complexity, here we can see that this for loop is running for 0 to 32, that is 0 to 31, that is 32 times, and this for loop is running for n, right? So if I combine this, it will be order of 32 into n, which is simply order of n. Okay, so time complexity is order of n, and if you talk about the space complexity, we didn't take any extra space, so it will be order of 1. Okay, in this way you can solve this problem. Don't worry, I'll give the link that how you can for the practice. It is actually present in the lead code, and the name of this problem is single number 2. Okay, and if you want a detailed explanation of this, I'll give you the medium link. In that I have written in detail explanation. Okay, and that's it from my side. I'll see you in the next video. Till then, keep practicing. Thank you.